So good afternoon, everybody. My name is Jelle ten Hoeven. I'm the head of research IT and the information security officer at the Netherlands Cancer Institute. As my day job, I'm involved in data lifecycle management. You see the data lifecycle over here, consisting of its 6 phases, 6 steps. And I am bound by 2 major regulations, you could say, the GDPR, the General Data Protection Regulations, and the NEN 7510, which is a norm for information security in healthcare. And on the other hand, we try to achieve, of course, fair data to have as much impact as possible with our science and the data that we generate for that in society. I'm going to tell you a story about a research collaboration, and this is the background of that research collaboration. It is a collaboration between the Netherlands and between Finland. You see that the Netherlands Cancer Institute and IKNL, also a Dutch organization focused on cancer, is collaborating with the University of Helsinki. And this is a data-driven organization. And this gives you a flavor of what type of data are involved. So clinical data, pathology data, genomic data, and the total size of volume of this data within scope of this collaboration is about 250 gigabytes. And we're dealing here only with the right side of the data lifecycle, which is about storing, using, and sharing the data. Internally at NKI, so the research group of computational pathology is my client, so to say. The mission of that research group is to get the right treatment for the right person at the right time. And what I really like about this research group is that it's organized as a team, right? So always it is organized as a team, but they really focus on what they made one of their most important principles to do team science. It's a diverse group. There are software engineers, PhD, postdocs, both from the clinical side as from the basic research side. I could spend 2 hours on explaining to you about the field of computational pathology. I won't do that, of course. But very briefly, what you see here is a figure of a cancer tissue. The blue dots that you can see here, these are all annotations of cells at the cellular level of that cancer tissue. There are also other colored dots in this figure. And this is an example of an important aspect of the research that's being done in this field. These annotations, there can be generated millions, tens of millions of these per image. These are fuel for artificial intelligence model development. And ultimately, what the goal is of this research group is to improve immune therapy, targeted therapies, and chemotherapy. Okay, so that's a little bit about the background of the collaboration. At NKI, we have a research life cycle. That's another life cycle, but this involves the production of research output. You see, very basically, I will mention it. So it starts with collecting literature, setting up a protocol, a data management plan, then conducting the research, do reference management, analyzing results, and of course generate the manuscript. So this is quite basic and well known, I would say, also within the surf community. But what we're involved here with is patient data. So that requires an extra step, and that is a review by the Institutional Review Board. And here I've listed some of the aspects on which the criteria that the Institutional Review Board is reviewing the project for patients' consent. There's actually also a real ex-patients or patients that are still under treatment that are part of the Institutional Review Board, so they also take the patient perspective into account. And also other types of criteria that are met here, or that should be met by the project. And once that is approved by the IRB, and this collaboration has been approved, of course. And in this case, of course, it is a collaboration, so there's an external party involved. Then the IRB requires a data transfer agreement to make agreements between the parties for what's been done with the research results and also about data protection. And that brings me to the GDPR, Article 32 to be exact, which states that organization must implement appropriate technical and organizational measures to ensure the security of the data. Okay, so now how this in practice goes. So I receive an email from Hugo, who is the group leader of computational pathology. Just a one-liner. Please, can we share the data as soon as possible? How it always goes, of course, with researchers. So then we discussed this with the team, of course. We have experience, of course. So there are basically three options. The team itself also comes with proposals. Using an open cloud or a public cloud service. Go for on-premises, right? Give the people from University of Helsinki access to NKI data center, or perhaps use the Serve Research Cloud. So if you evaluate this, then of course, with the first option, there are concerns regarding privacy and security. The on-premises option can be difficult, right? To get the people from Finland, to get them accounts on your local infrastructure, for example. So this is also not an optimal situation to be in. And Research Cloud, at the start, seems like a good solution because the key features of Research Cloud are that it has a turnkey solution for a shared workspace. There's SRAM authentication for organizational accounts, and we checked initially if Finland, the University of Helsinki, could be assigned, could be connected via SRAM, and that was indeed the case. And also within a few hours, within a few emails via the Serve people, this was arranged. Serve Research Cloud is known and trusted by both parties, as it seems like, and the Serve Cumulus contracting at NKI part is in place, and also at the Finland side, this was all in place. So because Serve is compliant with NEN 7510 and ISO 27001, the security standards. This was all very positive. And on top of that, we could request an A-infra request at NWO, so that the costs for hosting such a shared workspace would be covered by NWO. So then we come to the delivery phase. We did some magic. So we as the research IT team, we always do that as IT specialist. And pretty soon after we got the request, we were able to send a 5-bullet stepwise manual for 6 researchers, 3 from NKI, the Netherlands, and 3 from Helsinki, and they were able to start working in a shared environment. Here you see a screenshot of how that is configured in Research Cloud, and here you see a screenshot of what the actual collaborative workspace looks like, with a shared drive, and all 6 of them were able to log into this environment. There was a statistician involved who could install her favorite statistics toolbox, and also a bioinformatician who worked with Python was able to access the data and do the things they had to do for this collaboration. So that brings me to my last slide. So in summary, I told you about a multi-center data-driven research collaboration between the Netherlands and Finland. The setup was really fast for the collaborative environment. It was secure by design. There were no costs involved for the collaboration. And it was all powered by Surf Research Cloud, which in the end led to a group of very happy researchers to collaborate and do that all together. That's it for my part. Are there any questions?
Moment there are any questions yet?
Okay, then I hand over to Ivar.
Yeah, thank you, Jelle, for this nice presentation about European collaboration. Surf Research Cloud is mainly used for Dutch collaborations between our member institutions, but this one is an international part, and we're going to see that more often. I've talked a lot about Research Cloud itself, but I now want to focus a little of this time on more European things that we encounter, because this was also a European project. And the first question that you get is, well, why do you want to work together on the European level? I think, you answered this question pretty well, but I'd like to add another one. It's fun. It's really fun for us to work together with our European partners, like Finland, but also with Greece and other countries. There are different NRENs there, and they kind of have the same problems as we have. And if we find a solution, they can also challenge our ideas, because sometimes we might not have the best solutions, or they don't have the best solution, and we can kind of challenge each other on that. And that brings the best of both worlds most of the time. So eventually it will bring us also further than just doing the things ourselves. That's also the theme of Surf. And together we can travel further than just doing stuff by yourself. And that's because we can share resources. Very important point. There is a lot of support on these different NRENs around Europe that we can bring together to solve the issues for the researchers. And last but not least, in this way we can build what we need. And what I also sometimes see is that we buy something with a lot of features that we don't need, but now we can really look into things that we need for research, and that's different usually than for an enterprise setup. To talk a little bit about that, that's about the goal of Research Cloud is to get the compute to the data. There's a lot of data stored in Europe, and there are groups of people, like Jelle told us, who want to work with that data. And if it's small, this was not that big a file, maybe you can move the data to the compute. But a couple of weeks ago, I was at the medical center, and they said, well, we just bought this new machine, and you can put in a sample, and it will give you some genes and proteins and a lot of nice features. And I said, well, pop the question, how much terabyte does it produce then? Well, it's just about 200 terabytes for each run. Okay, and a run is about 4 days. So every day, around 50 terabytes of data is generated. And this is an expensive machine, so it's not the one that you just store in the corner and don't look at it. That's something that runs probably 24/7 to produce data. So these amounts of data you don't want to transport everywhere or copy everywhere. You really want to bring the compute or the analysis environment to the data. And that's also different than that you normally do with an enterprise where you have all the data in your enterprise and you just run it there. So this challenge is really different. And then you also, if you really want to do that, you need to support multiple clouds, and that's what Research Cloud also does. So we support the on-premise environments like the OpenStack environment that we have at Surf, our HPC cloud environment, but also on-premise environments, but might be also OpenStack at an institution, or European cloud environments, or the public cloud environments. And if you go to public cloud, I can implement something on public cloud Ireland, but that doesn't mean that I can access data which is stored in another location. And these multiple of these cloud providers, they are moving towards multiple regions. So you get more regions. There will be an AWS region here in Amsterdam as well. So I also need to be able to move to the different regions within the cloud provider. And then you don't want to have accounts on each cloud provider to do that work. You need a federated identity system to be able to log in on every cloud provider and run your application there. And yeah, of course, there are differences with each cloud in the billing, in the setup of the security, whatever that you encounter as a researcher to do that. So basically, you want to shield the researcher from having to know all these things, and that's what Research Cloud is trying to do. We're trying to automate a lot of this stuff for them so they can do their magic in this sense and just deploy the stuff that is needed. And we can do that now because there are new tools available to us, like infrastructure as code. We use a lot of Terraform, Ansible scripts, other stuff that we can combine to make it happen. And because these scripts can be reused, and they are being reused, they're automatically hardened, because every time you reuse something, you find faults or things that you want to improve. So by working in the same infrastructure, we kind of make it better for all of us. And we created it in a way that it's self-service by design. So that makes it also scalable. So a lot of groups and communities can work together on it and kind of work with us to make more functionality available within the system. We have, of course, the federated identity server resource access management, as mentioned, gives us access in a federated way to a lot of European colleagues and even international, global, I mean. We try to use as much international standards as possible because that makes it possible to work together. And Research Cloud has a grant, Horizon 2020 grant from SEANT, to work on these international standards. It's called CN43 Work Package 3 Task for Community Clouds, if you're interested in searching for it. And we have meetings regularly. The first one will be in Göttingen, Germany, to talk about what we're doing in Research Cloud. And on the TNC in Trieste, Italy, we will also be there to talk with our colleagues about how to implement this research infrastructure on a European level. So that's it for me. I think there's still time enough for Peter. Are there any questions?
No, not yet.
Not yet.
Ask questions involved, please do so.
And then we can change and maybe do the questions at the end of the meeting if they are. Yeah. Peter, go ahead.
Thank you. Good afternoon, ladies and gentlemen. I'm presenting on a new corporation we just founded, and Jelle is one of my co-founders and Bert Eusen is the other one. And the reason why we need this, we think, is that we need to treat data as a commons, as it's now called. And I will tell you more about it and also the relation and the opportunity we see working on this together. The corporation is called LabSpace Co-op because we believe we need to experiment a lot. And fortunately, we can, because we're in a lucky position, and I will tell you more about it. The co-op is driven actually by three parts. It's data, and data is very interesting because it has an anti-rival nature. It gains more value the more it is used. And this is very different from a lot of other products and services, which lose value if you use them. Then the second part is the data and data spaces, which is getting very hot now. And very important for us is that you need to archive and curate the data at the moment it's created. Otherwise, you will be too late, and it has to be sustained by a sustainable ecosystem. But to create value with your data, you need to synthesize it with consent, curation, and technology orchestration, and of course, knowledge contribution. And then you can get a return on data. Yeah, the way we set this up, and it's a startup, you can imagine. We're just looking, of course, to use our networks and our knowledge to build this. But the core is driven by consent. And that drives also the return on data and the value of the data in the ecosystem, as we call it. Also very important for us is to link it to the sustainable development goals, because we believe it should be all to the benefit of us and the planet, of course. The co-op has 4 roles. The top is the knowledge contribution and, of course, the consent of the data, which is done by humans. The data curation, which is separated from the technology and its orchestration. And basically we say you, as an end user consent holder, have the key to unlock your DNA or any other data and create value with it in a biodiversity world. And very important, we believe that not data is the new oil, but trust is the new oil. And this picture is coming from the next generation internet positioning side. And what we are in is basically a movement from centralized systems and services to a decentralized world, where everything is basically secure and private by design in a very decentral way. And that trust needs to be kept on all these layers. And of course, in the end user has to experience that trust, but you need to take care that it is delivered on all of these layers. And that's new. And then, of course, the question is, in the end, who do you trust? Do you trust you as a member of the organization? Do you trust you as a person? Or do you trust the person who's representing a community that they can trust? And we believe, and that's why the cooperative is membership driven, so personal membership driven. And it is a cooperative, as it says, because it's driven by people and people that want to cooperate and you can trust form the community. Very important development here in Europe is the European health data space. And we're very happy with that movement because it actually means that we have rules and principles on a European level where all the challenges of GDPR, artificial intelligence, universal European identity, medical device regulations are all put in a frame for a European health data space, which is designed from the citizens in Europe. So it's the other way around this time, and I like that very much. And of course, we have a lot of challenges because if you look at it from the side where we are, you see all these problems and the areas of work which they're working on the European health data space. Very important is that we from the research side are actually only interested in the right part, which is the reuse of data and secondary use as it is called. And the example we just presented shows you that this is actually possible now, because by using the existing European Science Cloud infrastructure and their federated identity management, we can give any researcher in Europe potentially access to a secure and scalable infrastructure where they can do their research. And of course, very important is to have a data space, which is connected to the European health data space, I believe, to manage all that data with consent in the right way. And then if you look at the picture that Jelle presented, actually, we think this is the best solution for research because all the other solutions are not ideal and certainly don't scale. That's the biggest problem. They really don't scale. And especially if you look at the European level, it's not, I think, and I believe, the way to go. Another very interesting development I've been in for more than 15 years, I think, is information lifecycle management. And the reason I show it here is that we really have to think about this. What you see with a lot of data, for instance, in the news or in primary care, it has a very high relevance at the moment it's created. but it's also a very short lifetime because after a few days or weeks, it's not used anymore. We all store this on clouds now, very redundant, very high available, but also very expensive. Then we have research, and research has a different attitude. It really depends on the research when data is used. And what you would actually need for that also is a long tier, a third tier as we call it, to make sure that the data is then also available after a few years from now. And if you don't have it, then the data is probably gone. And the nice thing with SURF, at least, is that they have also what they call a second tier, which is low cost, doesn't consume any energy, and basically can get all your petabytes of data. It's extremely scalable. And that's what we call an active archive. If you start using that at the moment that you have the data as an active archive, like they do in physics, but unfortunately not in other sectors, you have a very low cost, very CO2 efficient solution. And also your data copies are gone because they are archived by design. And you have a safe to store all this stuff. And important, you have to think about, because in the future technology will change, you have to migrate to new technology in the future. And this is, from a sustainable development effort, extremely important, because if you look in the potential saving, which you can do by moving into this development, it's an 87% reduction in CO2, which you can achieve at the moment that you start archiving, at the moment of creation and using this other environment. And I did a small calculation, and we need to check this because we really need to understand how much we use from an energy point of view. And unfortunately, we don't know that very well. But the example is given in this calculation shows that you can save with 10 petabyte of archive 2,600 tons of CO2. The SURF archive is 100 petabyte at this moment. So that would save you 26,000 tons of CO2. And what you need to think in mind or keep in mind that IDC estimated that our total storage in 2025 for the world will be 7.5 million of petabytes of storage. And if we do that in those nice clouds, which we have today, well, it will become very expensive and it will also not be very good for the environment. So that's why we believe you need to look at this by design. So how do we work from a community perspective? At the center, it's the data and the data commons, but it's basically a commons because we work together, where the citizen has his consent, the researchers work with their teams as a research group, as knowledge contributors, the data is curated, and very important, the technology is orchestrated. And we now have the European Science Cloud with Research Cloud at the center, basically. And we just need to add trustworthy applications to it to do the processing on it. And then I believe we're done. And we can then give a return on data value for the individual researcher, for the community, but also for society. So going back to the picture that Jelle presented, we think we have, if you look at that use case, everything covered except for the data. And this is a very big problem, I believe. The reason why there is still an exclamation mark at that data side is that for publication, the data is only released after it's published. So it can take some time till the data is really available. And nobody knows in between. It's also not accessible because the research group has access to it, but nobody else, which in fact is not right from a consent perspective, because we as citizens also should be able to say somebody else could use it perhaps as well. So we believe there's a fundamental problem with the way that data is curated, and we need to fix that. And that's why we're looking to do this by design and work together and create a new and better solutions where we do this in a much better and more valuable way. And that leads me to the end. You see here the four animals, and it's really the four stakeholders that work together and collaborate. And yeah, I would ask you to, as data curators and technology orchestrators, but also as research groups, to join us and start creating the data as a commons together. And you can contact us via the SURF community for Research Cloud, which is in the link, or me directly. And if you want to know more or have questions now, I can imagine, you're free to ask. And I think Jelle and Eva will join me also for their questions, so we can answer your questions now. Thank you. Yep.
There's already one question.
Yes.
The question is on Onbout.
Yep.
Jeroen, to be able to ask the question yourself.
Yeah, I can. And it's on applicability, more or less, not on the technical part. And I think the question, yes, mainly to Jelle, that is, how easy was it for the end users to start using the Research Cloud? Did you have to offer much support? And were they already tech savvy end users, or were they not?
No, yeah, so it was a very good question. Thank you for the question. It was really straightforward for them, right? So we gave them access to a Windows environment. So for the non-computational researchers involved, and the computational researchers involved could access also the Windows environment, but also Linux environment for for their specific applications. So basically, I have a research IT team. So and together with the support of a consultant at Serve, we set up the servers itself, right, in Research Cloud. And that also went really smooth with these technical guys. Does that answer your question?
Yeah, I think so. But so you provided the platform, and they installed applications themselves, or did you pre-configure?
So yeah, this is a bit technical maybe, but they were able to log in with a remote desktop application.
Oh, okay. Yeah.
Right. So this is how most organizations now work from with their home working environments. So for them it was sort of an additional home working environment.
Yeah, and that was prepared for them. They connected, and that was it. And then they started working in it.
Exactly.
Yeah. Thanks.
Okay.
Any more questions? No. Yeah, then I would like to thank you. But if there are coming in, you let me know probably. Thank you for sharing this with us. I think what we've seen is that with Serve Research Cloud, we created an infrastructure where we can help researchers already on an international level work together. And we also inspired some people to think further ahead in what would be possible eventually if we have the data management and the consent in order, because then we can even do much more with the data that's already available. And since it's very easy to give researchers access to data and the research and the processing environment, I think we can do a lot more in the future. And hopefully new ideas will pop up. And if somebody has them, please let us know, because we are looking for new ideas on how to use this infrastructure. And there's a question. Yeah.
I see Mr. or Mrs. Huiberts is asking, what is the difference with the DRE initiatives?
Shall I take that one?
Yes.
There are multiple virtual research environments or digital research environments. If I look at Research Cloud, it's a cloud management portal, but it's the difference is that we use infrastructure as code as much as possible. So if you deploy something, it's already in code, so you can deploy it on Azure, or you can deploy it on AWS or on our OpenStack environment. Doesn't matter, the code is the same code. And we try to make it transparent or cloud agnostic for you. And other DRE environments that I'm aware of, they kind of work on one cloud provider or on an internal institutional account. And here we try to be really multi-cloud and even multi-region aware, since we need to bring compute to the data, and data can be stored everywhere.
And I think a very important thing to add to that is that the SRAM, which was mentioned, the Research Access Management Identity Service, that is key. So even if you would have a DRE or something else, you would need something like Server Resource Access Management to federate and work together in a secure way. Otherwise, you have the problem that you cannot work together with other countries. And basically, that's why this is such a good example. It was very easy to set up this collaborative organization by using the standard network infrastructure, which is much, much more secure, actually, than a lot of other infrastructures which are in place. So I wonder if you would do a risk assessment on both environments, which would be the better solution. Eva, you can mention that as well.
Yeah, well, thanks for that addition. And of course, yeah, with Research Cloud, we try to reuse a lot of the services that we have. And so iRODS for our data management is used, Research Drive is used, SRAM for identity management, HPC Cloud. So we are kind of connecting everything together.
Well, you're getting a thumbs up.
Oh, no. Please join us. And,
yes, please contact us.
Contact us, and we'll see what we can do.
Thank you.
Thanks.
Yeah, thanks.